Hi, I'm Hamad Zamani, and I'd like to talk to you about our research on proactive conversational search and recommendation. Just a little bit information about me. I'm an assistant professor at UMass Amherst in the College of Information and Computer Sciences. I also serve as the associate director of the Center for Intelligent Information Retrieval. My research interests are developing and evaluating statistical and machine learning models with application to information access systems such as search engines, recommender systems, and question answering. And my current projects involve developing neural models for information retrieval tasks, weak supervision for information retrieval, and also conversational information access, which is related to this presentation. Just let's look at an example of how users interact with a search engine, which is basically one of the most important and most successful applications of information retrieval and computer science in general. Assume that I'm looking for information about coronavirus while traveling. So I search for coronavirus and go through the result list, look at the documents. I may click in some of the documents. And if I don't find the information I'm looking for, I reformulate my query. I search for coronavirus travelers. And then I go through the result list. If I don't find the information I'm looking for, again, I reformulate my query. And then here we are. The first link is the actual relevant documents, the ones that I'm looking for. So with this example, I'm just showing that how limited are the interactions that we can take with search engines. The users can just submit a query, the system responds with the result list, with the search engine result page, and the user can just click on one of them or just submit another query. But think of these devices with limited bandwidth interfaces, such as small screens, or in this extreme case, a system with no screen and voice-only interface. So the users cannot go through the result list using this interface quite easily. We believe that we need to go beyond this query response paradigm that we currently have in the search engines. The systems can be able to take different actions other than just responding to query and providing a result list. But one may ask why this is the right time to focus on conversational information seeking and why this is the important problem. The first reason is the recent advances that we observe in automatic speech recognition. We can get reliable transcriptions of speech utterances in several languages for many different accents. So these are just some becoming a reliable way of interacting with the systems. Devices with limited bandwidth interfaces are becoming more and more popular, and users are spending more and more time interacting with these devices. The third reason is the recent advances in deep learning that makes natural language processing and generation more powerful, and we can kind of imagine how we can generate responses to a lot of queries instead of just retrieving them. And the last one is the importance of information access in all of these systems. Everywhere that we have an intelligent system with a lot of information, we need to provide a gateway to those information. We need to provide a way that the users can access those informations. And search is definitely one of the ways to provide these access. So there are a lot of challenges, major challenges in developing conversational search and recommendations. The first one is these limited bandwidth interfaces. Most importantly, when we want to present the result list, we need to develop models for multi-document summarization, or more importantly, explaining the result list to the user. These systems often consist of multi-turn interactions. So the system needs to be stateful and interactive. They should be able to keep track of all of the previous interactions that the user had with the system. The third challenge is about multimodal interactions. These devices that we deal with usually have different modalities for interactions, for example, speech, screen, and we can imagine different ways of interacting using virtual reality and augmented reality devices in the near future when people want to just make conversational interactions with these devices. The last one is the need to go beyond this query response paradigm to make mixed initiative interactions in conversational search. This is the actual focus of this talk. Let me give you an example. When a user searches for a query like COVID-19, instead of showing the result list related to this query, the system can decide that, okay, this is an ambiguous query. This can be related to, for example, general information about COVID-19, or it can be about new cases, some new statistics of COVID-19. So the system can decide, instead of showing the result list, let's ask a clarifying question to make sure what the user actually needs. For example, said, what do you want to know about this medical condition? The system can also show some predefined answers, some candidate answers to its clarifying questions, such as symptoms, precautions, recent news. Clarification is one type of mixed initiative interactions that we are looking into. And we developed a general framework for generating these clarifying questions in open domain setting, and for example, web search setting. In this framework, for each query, we have a query aspect generation component, which kind of generate all of the aspects of the query. These aspects can be generated from a knowledge base, in the simplest case, or it can be mined from search logs or the search engine result page. Once the aspects of the query are generated, then we generate the question using an encoder-decoder neural network. This basically encodes all of the aspects that we generated in addition to the query, and then the decoder generates a natural language question. The third component generates a set of candidate answers for this question. The candidate answers can be selected from the query aspects, or they can be generated from the question itself. And at the end, there is a clarification utility function, which kind of is used for optimization of our model. This component maximizes the probability of it clarifying the user intent by asking the question. So basically, it's maximizing the probability of C equal to 1 given the query, clarifying question, and candidate answers. C here is a binary random variable where C equal to 1 means the different user intents are clarified using these clarifying questions. We have developed two public benchmarks for these tasks. One of them is small scale with 200 queries, but the questions and candidate answers responses from the users are all human generated. We collected them through crowdsourcing. The other data set contains over 450,000 unique queries. These are all real queries submitted to the Bing search engine. This was created with our collaboration with Microsoft. And the questions in these data sets are machine learning generated using a model similar to the one I just presented. And this contains a lot of real user interaction signals, such as click on each individual options. Let's go beyond clarification. For designing proactive conversational systems, the systems should be able to initiate a conversation. For example, once there is a conversational system sitting there, and once they decide to initiate a conversation, talk about something, we compiled a taxonomy of agent-initiated interactions. It has three dimensions. The first one is initiation moment, basically answering the question of when to initiate a conversation. It can be instant initiation for scenarios where it's, for example, related to health or safety that we need to instantly initiate a conversation. Or it can be an opportune moment initiation. We need to wait for a suitable time and then initiate the conversation. The second dimension is about initiation purpose. Why to initiate a conversation? There can be different reasons. For example, filtering some streaming information or following up a past conversation. For example, you had a conversation with the system in the past and the system provided a wrong answer. And later on, based on new information, based on new deployment of new models, they understand that, oh, we provided a wrong answer. They can follow up. Oh, do you remember that we talked about this question and I gave you this answer? Okay, I was wrong and I realized that this is the new answer. This is the correct answer. They can also contribute to multi-party human conversations. For example, two people are talking and one of them says that, okay, only a couple hundred of people have died of COVID. So the system can run a fact checking and initiate a conversation due to some credible sources. Unfortunately, we have lost over 500,000 people in the United States due to the COVID. So these are different purposes of initiating a conversation. And the last dimension is about initiation means, or how to initiate a conversation. For example, if the user has multiple devices, or if the device has multiple modalities, which interaction modality should be used to initiate a conversation. We developed a high-level framework for initiating conversations. Basically consists of the first component is related to initiation purposes. So it gets all of the information such as past user system interactions, user profile, streaming information, and then identifies what are the information that we want to produce, what are the initiations that we want to make. And then there's an initiator component, which is about initiation moment. So it decides when to initiate a conversation. And once it decides that this is the right time to initiate a conversation, the third component generate the conversation and select the modality and the device and kind of interact with the user with the initiated conversation. To make all of this research possible in the research environment, and also with practitioners when they want to kind of build new systems, new models, try out new scenarios, we developed an open source platform for research and conversational search and recommendation. It's called Macau. It's available in the link in this slide. And the Macau is basically using a modular architecture. It consists of processing the interaction that the user had with the system, logging all of these interactions, and then dispatching these interactions towards multiple information access systems: search, recommendation, question answering, generating clarifying question, and so on. And then at the end, it decides, okay, what response should be chosen, what modality, and then represent the results to the user. This is an example of an interface that we had in Macau. It's basically supports multimodal interactions. The user can talk to the system. It has automatic speech recognition. It provides different types of responses, such as text or a list of clickable options or links or images, and so on. And these are just some examples of the work that we do related to proactive conversational systems. There are many more. For example, joint modeling of search and recommendation, developing models that jointly represent items for search and recommendation. Multimodal conversational search and recommendation, supporting multimodal interactions and also multimodal information items. Modeling and measuring conversational search and recommendation, especially, especially through an economic model of conversation by estimating the cost and benefit of each interactions and estimating what would be the optimal interaction that we can take at every moment, and many more. At the end, I'd like to thank all the collaborators I had throughout these years. And in this, I'd like to talk a lot about the research that we do at the Center for Intelligent Information Retrieval. It's not just about conversational search. We do a lot of fundamental research about deep learning for search engines and recommender systems. We work on misinformation and controversy, and also explainability and fairness. Um, so feel free to reach out if you are interested in any of these problems. Come talk to us. There's is the link to our websites. Go and check out our kind of current and ongoing projects. Look forward to hearing from you. Thank you.